are live. Hello, Freek. How are you doing today?
Good, thanks. How are you?
Yeah, I'm very good. So we are going to talk about Project Bicep, and just wanted to introduce yourself and just start the lecture.
Yeah, sure. So thank you for joining, everyone. And in the next 45 minutes or so, we'll be talking about Project Bicep. So some of you might have heard about Project Bicep being introduced a couple of weeks ago, and especially if you have been following the Ignite conference as well, you might have heard and seen it before. But it's a new technology, and I'm excited about it to share some of that with you today. So as an introduction, my name is Freek. I am from the Netherlands. I primarily focus on application and desktop delivery using remoting technology. I do that as an IT consultant, as an architect as well, mostly for Dutch customers. And yeah, I've been in this space for many years, part of the MVP program. I enjoy sharing knowledge at community and conferences like this. So if you want to connect later on, I have my Twitter email account on screen. And if you want to connect on LinkedIn, please scan that QR code. Happy to connect and talk about this topic some more later on as well. So, well, thank you for having me at this event, Gisli. It's good to be back. And well, the picture that you see on the slide right now, that's actually taken almost a year ago. We were just discussing that it feels like 3 months ago. But this was almost a year ago when I was visiting Iceland and presenting at the same conference in person, which was great fun. And also spent some time exploring your country, which is great. So I hope to be back someday, and hopefully also bringing the family to explore your country some more. So as I said, I've been focusing on desktop delivery a lot. So Windows Virtual Desktop, RDS, and similar technology, mostly on the Azure platform. And if you're familiar with technology, you might know that Windows Virtual Desktop, the technology itself, came out of preview close to a year ago. So I have seen a lot of demand for this service to be able to publish applications and desktops to an end user based on the remoting protocol. But obviously, we got another big boost for this service based on the whole COVID-19 situation, of course. So I've seen a lot of demand from customers who realized suddenly that they do not have a work from home proposition for all of their users and all of their use cases or all of their applications. So I've been helping a lot of customers embrace Windows Virtual Desktop and similar technology. And so I want to quote Satya Nadella, who recently said that we have seen digital transformation take place in 2 months, where it was the demand for at least 2 years. So a lot of customers have been moving and towards digital transformation to be able to support a modern workplace, modern applications, and well, basically supporting a work from home scenario. So Microsoft also saw that, and this is what they shared already back in March, where they've seen a huge demand increase for these services. So not only Windows Virtual Desktop, but also Teams and Microsoft 365 in general. They have seen a huge demand grow over since the beginning of this year. And Windows Virtual Desktop was one of the things that was mentioned here, where they noticed a growth of 3 times, which is crazy if you think that the service was only generally available for a couple of months before that. So as an introduction to the topic of today, it's automation in Azure, obviously. But I want to start off with this question. So what do you think that the main driver is behind automation? You don't have to answer, but let the answer sink in for a bit, because if I ask this question to a live audience, I get a lot of feedback saying, we do automation to make sure that we have fast deployments, that we have deployments that are that we can reuse for our different customers or different subscriptions. We want to have infrastructure as code and so on. But actually, I think I have another answer as to the main driver behind automation, which is the screw problem. So if you're not familiar with this is a caramel flavored cookie, really popular inside and probably even more popular outside of the Netherlands. And for me, this is the main driver behind Azure automation. And here's why. So 3 years ago, I presented a session at a conference in the US, in Florida, where I presented at the Experts to Experts conference, a session that was called Grab a Stroopwafel while we watch ARM do an automated deployment of RDS in Azure IaaS. So I literally went on stage, handed out stroopwafels, and we watched an ARM deployment from start to finish, live on stage, deploy an entire RDS infrastructure in about 40 minutes. So I did also bring a huge box of stroopwafels to the US, which apparently is a challenge if you want to go through customs at the airport, but I managed to get through. And so we enjoyed that stroopwafel, and while we were doing that, we were taking a look at what has been created. So a lot of objects in the Azure subscription, so managed disks, network adapters, virtual machines, availability sets, these were all created based on Azure Resource Manager JSON templates. On top of that, we also created an entire RDS infrastructure. So joining the VMs to the domain, publishing the RDS properties, doing all of these certificates and the policies and the settings, etc. So long story short, within 40 minutes, we had an entire RDS deployment in an empty Azure subscription that we could literally take to any Azure subscription and have it deployed over there. So just an example of the power of automation and Azure Resource Manager in specifically for these scenarios. So yes, it is the stroopwafel, but of course it is also about the other stuff that I mentioned. So having fast and consistent deployments, customizable for different subscriptions or different customers, and also, well, being able to deploy it in exactly the same way for your test or your production or for your staging environment. So let's dive into the automation part. So this is a diagram of Azure in general, and more specifically focusing on Azure Resource Manager. And so without going into detail on all of these components, the idea here is that whatever you deploy in Azure, whether it's a virtual machine or a network adapter or a SQL server or VNet, they're all based on ARM. And because they're all based on ARM, we have a consistent deployment and a consistent manageability for all of these components. So resource groups, subscriptions, tagging, role-based access control, that is all alike. On top of ARM, on top of Azure Resource Manager, the engine itself, there are different ways to interact with that engine. So I could go into the Azure portal, start creating objects using the UI. I could go into the command line interface, use PowerShell, REST API, or any SDK that is available. So my message is that if you want to be successful with Azure in general, or well, maybe with any public cloud for that matter, you would really need to start embracing automation to fully leverage the power and the options of an Azure cloud or a public cloud in general. So in this session, we'll focus on Azure Resource Manager and more specifically on ARM templates. And on top of that, what Project Bicep has to offer to really empower the authoring of ARM templates for your automation. So taking a look at infrastructure as code, if you're not or less familiar, it's based on an ARM template, which defines which objects are going to be created in the Azure portal. And on top of that, I can specify what's called a parameter file. So I can take the same ARM template and deploy the exact same set of objects in different subscriptions for different customers by using parameter files to be able to customize that deployment as well. So that ARM template is built based on JSON language, JavaScript object notation language, which basically means it's an XML-styled document, a plain text document, if you will. And it's the industry standard, and it's used across every object in Azure that's based on the ARM engine. So you can see that we have the default properties like the parameters, the variables, the resources, and the outputs. We'll take a look at some examples later on. So you could use any tool to be able to author these ARM templates because it is just plain text. However, the advice is to use a application that's also providing you additional benefit on top of that to make your authoring easier. So what I personally use is Visual Studio Code, which has some great interactions with the Azure portal, as well as some intelligence around well, checking the markup of your language to make sure that it is correct. So we'll take a look at a demo in that area as well. So where do you start then? Do you just go into your editor and start creating a new ARM template? Probably not, because, well, you don't have any knowledge on where to get started. So what I always advise for people who are new to this technology or want to learn how to author ARM code is by simply going to the Azure portal, creating a random object there, whether it's a virtual machine or a VNet or whatever you're creating. And right before you hit deploy, download the actual ARM template, including the parameters file. This allows you to open that same template in your editor and start reverse engineering of what that ARM template looks like. That gives you a great way of well, investigating what is needed in an ARM template and build your own customizations on top of that. So it's a great way to learn from existing ARM templates by deploying them and seeing what happens behind the scenes. Another example, a great way to start learning is taking a look at the Azure Quick Start templates area, the GitHub area, where a lot of templates have already been shared with you, including documentation and ways to interact with those templates. So whatever you want to create in the Azure portal, check out these Quick Starts guides before you do that, because there's a great chance that somebody already authored what you want to create, and you can build your own ARM templates customizations on top of that as well, to give you a head start on your authoring. So I want to quickly go into a demo of ARM templates to give you an idea of the JSON code behind that, and afterwards we'll take a look at what Bicep has to offer on top of that. So I'm going to switch to my editor, which is Visual Studio in code, and I have my JSON file here. So this is that same JSON file I just mentioned that deploys an entire RDS infrastructure in any subscription, including all of the components. So as you can see, these are a lot of lines of code. This is, well, over 1,700 lines of code. So I'm not going to go through all of them, just to give you an idea of what is part of such an ARM template. We have seen those 4 different sections. So parameters, variables, objects, and output. And here we start with the parameters section, which allows me to identify which parameters I can pass towards this template to be able to customize it. So just to give you an example, I can specify the Active Directory domain name, in this case, the local admin account, but also things like the location where my scripts are that I'm allowed to extend on this ARM template as well, my PowerShell scripts. So I'm not going to go over all of these parameters, because, as you can see, it is a big list. It has over 70 different parameters. And so the reason that I have this amount of parameters is that I allow a lot of customizations for this ARM template. So without changing this ARM template, I could take this into any Azure subscription, pass the correct parameters file, as we'll see in just a minute, and be able to customize this template for that specific environment. So that's parameters, allowing you to customize. The other main section is variables, and this allows you to specify certain values, certain variables that I'm using across this template multiple times, maybe, in order to have them configured at a single level. So here are my variables, just to give you a couple of examples, the ports that I'm using for this RDS deployment, load balancing stuff, but also more advanced parameters where I have, variables, where I have a single variable and a couple of sub-variables as well. So, and then we get into the main section, the third section, which is resources. So this is the place where I define which resources are going to be created in my Azure subscription. So to give you an example, this is the resource that is creating a public IP address, for example, for a virtual machine. So I specify the name, the comments, some tagging, location, and some properties of that public IP address. So this is ARM defining what should be created in the Azure portal. Similarly, I have objects that create availability sets in this case. And for example, also things like load balancers, etc. But let me scroll down to, for example, a virtual machine, just to give you an idea of what is in there. network adapters, load balancers, network adapters, virtual machine. So here is a object of type virtual machine, where I'm creating actually multiple virtual machines within this single piece of code. So I have a copy statement here, which allows me to run this part of the code for X number of times. So I can specify the parameter number of instances for this machine type. And if I would enter that 5 here, 5 virtual machines will be deployed, will all be added to the domain, and all of them have the extensions available. Important thing to mention, because we'll see this in Project Bicep as well, is depends on sections. So if I create an object in Azure, I have to explicitly tell the ARM engine which objects it depends on, because those objects have to be created first before I can create the virtual machine. So in this case, the availability set and the network adapter need to be created first, and then the virtual machine can be created. So I, as an author of this template, have to provide these explicitly to the ARM engine, because otherwise the deployment will fail. So I could go ahead and actually deploy this entire template from this console as well by running the new Azure Resource Group deployment, specifying this JSON file, specifying my parameter file, and launching it right here from the console. But I actually want to show you a different way, is by using the Azure portal itself. So this is my Azure portal, and I have a couple of templates available. And this is simply a copy of the one I just showed you in Visual Studio Code. So if I would deploy this right from here, I will be able to specify the values for the parameters, for those 70+ parameters that I had, in order to deploy this in my Azure subscription. So I would, for example, create a new resource group here. Let's call it Iceland RDS for now. And as you can see, here's that same list of parameters. Now, some of them have default values, just to make it easier for the admin to fill this in. But so I could go ahead and fill out all of these parameters manually by hand. But the other way is providing it a ARM template parameters file, which I'm going to do right now. So I'm going to upload a parameters file, which is Azure Deploy Parameters JSON. And if I save that, then all of the values that were inside that parameter file are now entered into my deployment. So this allows me to take that same template as we saw in the diagram and deploy it against multiple subscriptions for multiple customers by providing it a parameters file in order to customize it for that specific deployment. Notice that this template also contains some other features, like, for example, I have defined drop-down lists in order to select, in this case, the licensing model, or in other cases, password change enablement, but also the VM sizes. So these are easily pickable from a drop-down list when the admin is deploying this. So this deployment, again, takes about 40 minutes, and it deploys an entire RDS infrastructure based on my ARM template. So let's now go ahead and switch to the main topic of the session, is how can Project Bicep extend and empower the authoring of my template? Before we do that, quick check. Are there any questions, Gisli, in the chat window?
No
okay.
questions.
All right. So if there are questions, feel free to add them in the chat, and we will interrupt and answer them. That's no problem. So taking to the main topic, so we've seen ARM templates, we've seen part of JSON code, and we've seen, although it's very powerful, it's also very complex, right? If you take a look at the syntax of an ARM template with all of the brackets and semicolons and comments and stuff like that, it's complex to author. So this is where Project Bicep comes in. So what is Project Bicep? If you're not familiar or less familiar with it, it is a DSL. So it's a domain-specific language, which means that it's not replacing ARM code. It's not replacing your JSON files, but it's extending on top of that. So it allows me to create a JSON file without having any knowledge of JSON, without having any knowledge of ARM. I could go ahead and create my JSON templates. And the reason is that Project Bicep allows you to create a Bicep file, as we'll see in just a second, which allows us to transform and transcode that into a JSON file using the Bicep language. So therefore, it's an abstraction layer on top of ARM. It's not replacing ARM, but it's allowing you to create your ARM templates in a much easier and much more effective way. So why did Microsoft do that? They noticed that although other ways are, you have other ways to deploy objects in Azure, like the Azure Portal and REST API and PowerShell, but they noticed that 70% of all declarative resources are still being created by ARM templates. So they want to make that experience easier by allowing you to use Project Bicep to alter those templates in a much easier and faster way. Oh, this is a simple diagram of the one we saw before about Azure Resource Manager, just to give you an indication of where that Bicep language is inside the diagram. So we have Azure Resource Manager. On top of there, we have our ARM templates and our parameters file. And on top of that, we have the Bicep language, which is actually a .bicep extension of that file as well. And the engine allows you to convert a Bicep file into a JSON file. So it's much easier to author. We'll take a look at some examples in just a second as well. And it allows you to leverage anything that is inside an ARM template. So anything you can do in an ARM template, you can also do in a Bicep language, because we're transforming and transpiling those files. It also allows you to do a much more modular approach. So by extracting and by consolidating some parts, and it's fully open source as well. So you will probably see a lot of more Bicep files end up on GitHub and on all public resources, in order for allowing us to share code in there as well. And in fact, even the entire Bicep project is available on aka.ms/Bicep, which contains all of the source, all of the examples, and a complete tutorial to get started. We'll take a look at that at the end of this session as well. So just to give you some of the goals that Microsoft had for Project Bicep, it is primarily used to reduce the pain when authoring ARM templates, allowing you to more easily adopt JSON language. And it's entirely, as we said, compatible with any existing template. It's a transparent abstraction layer on top of JSON. And some of the non-goals were, they did not try to invent new technology. They did not want to replace ARM. They just wanted to make it easier to be able to create the ARM templates based on the Bicep language. So we'll see it in action in the next demo that we're going to do. But before that, how do you get started with Project Bicep? If you're not familiar or new to this technology, there's 2 steps that you need to take. First of all, obviously you need an Azure subscription and you need your code editor. But the first step is that you install the Bicep CLI. I'm going to share this code, so it's in the slide deck, but I'm also going to share that code at the end of the session as well. But here is a summary of what this code does. I did not author this, by the way. This is what Microsoft provides in their docs pages and in their GitHub pages. But it downloads the Bicep library, installs it for you, and makes it available in your code editor. That's one option that is required, and then the next step is optional, which allows you to also add the code extension for Visual Studio Code, which allows a much better integration and the code editor also recognizing .bicep files and helping you to fix errors or fix errors inside your Bicep files. So I can really encourage you to install that as well. This takes you 5 minutes to complete, so there are no other requirements needed. So without further ado, let's take a look at a demo. So let me open up the code editor again, and I have already, of course, installed the Bicep language here, but just in case, here's that same PowerShell script that I just shown on the slide deck, and I'm going to share that at the end of the session as well. If you want this, within a couple of minutes, you have the Bicep language available. And the first thing that you'll see if you create a new Bicep file, let's go for the main.bicep example here, is that on the, let me just zoom in just to make sure there is a, oops, sorry about that, Bicep, wrong screen, Bicep language in the bottom right corner, indicating that the editor is recognizing this as a Bicep file, but it's empty. But the first thing we'll do is we will build a new Bicep file based on an empty Bicep file, and I'm going to show you why that is in just a second. So we'll select, we'll type Bicep We'll build, and we will enter the name of this file. So within a second, it created a JSON file based on this empty bicep file. So what is in there, if I open it up, here you can see an empty JSON file. So this is the JSON file that Azure expects with all of the sections that we covered before. So the parameters, the variables, the resources, and the outputs. And it did that based on an empty bicep file. So this is our way of making sure that the building process works and that we're actually getting an output. So this is obviously an empty file. So let's take a look at a more interesting example, which is a demo bicep file, which creates a VNet for us. So as you can see, the code editor recognized that this is a bicep file, and it already went ahead and did all of the color coding and stuff like that. So that's all in here. So as you can see, there is a big difference if you have seen ARM templates before, and in the demo a couple of minutes ago. This code is much more clean than your average ARM file, because I do not have all of those overhead of double quotes and semicolons and brackets and stuff like that. So it's a really nice and clean code. So similarly, I could go ahead and build a similar file based on this third file here. So let's go ahead. And again, in a second, I have the JSON file that corresponds to this bicep file. So let's take a look at the differences. So on the left-hand side, sorry, that was the wrong file. On the left-hand side, I have the JSON file. Sorry, that didn't go well. There we go. Left-hand side is the bicep file. Right-hand side is the JSON file that was being created for us. So as you can see, this is a full ARM template that is ready to feed into the ARM engine in my Azure portal to create, in this case, a VNet. So you can clearly tell that the way to, for example, create parameters here, that's only 4 lines. If you compare that to how to create parameters in JSON, it is, well, a much bigger list, right? So we're taking away a lot of the complexity, a lot of the syntax that is coming with a JSON file. Similarly, if you take a look at the number of lines, this is 38 lines, and the number of code lines for the JSON file is 60, right? So we took that in half, and we, less code and much more readable for the admin. Also take a look at things like, for example, creating a new variables with a concatenation of different values. Compare that to the way you have to construct it in ARM. So it's not really complicated, but there's a clear difference in the right-hand side and left-hand side when it comes to complexity and how to create these parameters. Also, if I wanted to add a new parameter, I could just type PA here, hit enter, the parameters here. And as you can see, it guides me through the process of creating a new parameter just like that. So it really helps you based on the integration that we installed to alter these bicep files even further. And similarly, if I would go to the variables here, as you can see, the tab completion guides me through the process of creating these variables in an easy and fast way. The resources, if I would want to create a new resource, for example, a virtual network, you can see that the tab completion is really helpful for me in selecting and creating this object in a fast way. So the first thing that I notice is that, well, first of all, it's really clean code, allowing you to not have to worry about all of the complexity, and also it's really helpful in authoring the code because it's supporting you with tab completion and all of that. So that's an example of a first object. And I want to take a look at another object. Let's not save this, which is a virtual machine. So we added some more code in this example, and let's just, without further ado, create the corresponding JSON file. Error, or didn't I get an error? Well, as you can see, this is a live demo. Not sure what's happening here. Could not find the file. That's interesting. Let's try it again. Bicep. for VM. There we go. Might have made a typo in the naming there. So the JSON file is now created, and again, if we open up this file here, we can see that all of this JSON code is created for us based on the relatively simple bicep file that we selected and created. So in this case, we're creating a couple of objects. We're creating a virtual network, a network interface, and a virtual machine, which much more cleaner code compared to the overall JSON file that has been created for us. So of course, since this is a full JSON file, I could go ahead and actually deploy this in my Azure portal. So here's that great new AZ resource group deployment that we mentioned before. And it's now leveraging that template file. So let me enter in a demo variables here for the local admin and the password. And it will now take the JSON code that we created as part of the bicep file and deploy it in Azure. So right now, a virtual machine, network adapter, etc., are going to be created in the Azure portal. So just to give you an idea that I'm not cheating here, this is that empty resource group. If I refresh it, we should see some variables here. Might still be working. There we go. So right now it is deploying these objects in my Azure portal. So the VNet, the network adapter, and the virtual machine are now being created as part of the JSON file without me authoring any JSON code. So only touching the bicep stuff, transforming that into a bicep file, and then simply feeding it to the ARM engine. And it's now completed. So if we shift here, take a look at the deployments, we can see that it finished in 51 seconds, which is crazy if you think that, this was only, this was a simple example, just single virtual machine, single network adapter, and VNet, but it had been created in 51 seconds. So going back to the Azure portal and refreshing here, we can see that the virtual machine, the network adapter, and the disk and VNet are now available. Last example I want to show you is Windows Virtual Desktop. I mentioned that this is my, the area that I'm mostly focusing on. So I, of course, have a WVD bicep file here, which I already went ahead and compiled. So let me open that up on the other hand here. So just to give you some more examples of the other stuff that the bicep engine actually does, besides the fact that we have transformed this from 41 lines to 75 and taken away a lot of the complexity. There's one thing I want to mention here is that if you create multiple objects, we talked about those dependencies in your JSON file, and this is the way in Bicep to be able to refer to a property of another object. So I'm creating what's called a host pool here in Windows Virtual Desktop terms. And when I create the application group, this is the easy way for me to reference the resource ID of the host pool that I created before, just like that. If you compare it to the ARM code that is needed for that same application group, this is the line of code that you need in order to do that, right? As you can see, it's much more easy to be able to point to existing objects and get their resource IDs. Also, what it did, as you can see, I'm creating this this application group here without mentioning any depends on section, right? I'm not explicitly telling the ARM engine, or in this case, the Bicep engine, that it needs to create the host pool first and then the application group. But because I'm referencing an ID here of another object, what the Bicep engine did is auto-create the depends on section for me automatically. So it's right here without me having to worry about that, which I think it's really awesome because the depends on sections can become really complex if you have to explicitly start referencing those all the time. So I think this is a great addition on adding that using the Bicep language. So similarly, we could go ahead and build the same stuff in the Azure portal as well. So we have the JSON file that was being created by the Bicep transpile. Let's go ahead and deploy that as well in the Azure portal. So we're now creating a Windows Virtual Desktop host pool, application group, and workspace, and also connecting these objects together using that implicit depends on that the Bicep transformation did for us. So let's go back to the Azure portal, take a look at the deployments. And as you can see, this actually finished in 2 seconds, which is even more impressive. But in 2 seconds, these objects were created. So if we go back to the resource group here, and we hit refresh, we should see that a host pool, a workspace, and an application group, if you're familiar with Windows Virtual Desktop, you'll know what these objects are, but have been created in the Azure portal. And even if I would go into the host pool, for example, take a look at the application group, you will see that the application group we created is also connected inside this application group as well. So all of the objects are now available and ready to use. So just as an example of another use case for Bicep, but basically anything that you deploy in the Azure portal can now also be deployed using the Bicep language. So I hope those demos were interesting. At the end of the session, I'm going to share that code with you on my personal GitHub as well. If you want to go ahead and well, start reusing that code, that's no problem. So just to give you a roadmap on what's happening for Project Bicep. So this was first introduced in late August, where we've seen the first releases come out on GitHub. A couple of weeks ago, it was officially announced. And also during the Ignite event, we've seen use cases and sessions about this technology as well. It's really a 0.1 version, so please be aware that changes are coming up. And for right now, the messaging from Microsoft is do not use this for production environments because they are making a significant change once they go to the 0.3 version later this year. So yes, you can start using it to create your ARM templates, but the messages do not use it for production yet because you might break things that are not there in this version yet. But it does allow you to get an early head start on the creation of Bicep because the whole concept will remain, but underneath there are changing some mandatory things that are changing across these versions. So what expected is very soon is an 0.2 version where they added even more IntelliSense functionality inside VS Code, support for the modularity we touched on in the introduction. And then the 0.3 version, hopefully at the end of this year, contains all the things that we have in ARM templates today in terms of creating loops and conditions. And from that moment on, it will be ready for production environments as well. So I started using it a couple of weeks ago. I was impressed by the way it allows you to create ARM templates without having any knowledge of ARM. Obviously, it does help to have knowledge about ARM because you can clearly see that what the Bicep engine creates is actually correct ARM code. But it's going to be really helpful in the future for creating even more complex ARM deployments using this Bicep language. Oh, where to get started, I mentioned this aka.ms Bicep link. It takes you through a GitHub repository. And inside that GitHub repository, you have example files, some of the files that I showed you today as well, but also an entire tutorial, which takes you through all of the steps of installing the CLI, creating your first Bicep file, transpiling it, transforming it, and all of the steps that I showed you today. So I did this tutorial a couple of weeks ago. It was helpful for me. So I would encourage everyone who's interested about this technology to take a look at that. It's available on GitHub and also allows you to contribute to all of the code as well because it is all open source. I mentioned that I'm also sharing some of the things that I created. So on my personal GitHub, you can find the Bicep files that I created, but also the ARM templates, the PowerShell scripts as extensions that I used inside these demos. If you're interested in that, feel free to check it out and contribute. Or if you have questions, feel free to reach out to me. I'm happy to answer those as well. So with that, I think we are, well, close to 45 minutes. We have a couple of minutes left. Maybe there are questions. If not, I want to thank you for your attention. I hope this was valuable. Again, if you want to connect afterwards, email, Twitter, LinkedIn, that's totally fine. And again, the link to my WV repository on GitHub if you're interested in this, well, the parts of this code, so to say. So if there are no questions, Gisli, do you have anything to add?
No questions, but this is really interesting. It really shows the power of infrastructure as a code. So there are a lot of scenarios that we can use this. For instance, if we have a university that's deploying VDI machines for students, it will really help in that scenario. Development environments and so on and so forth. So it also simplifies everything around the ARM templates. It really does. You know, all the I've heard technicians talk about, you know, there are these ARM templates is too much to look at.
Yep.
So it really scopes what you really need in the code with the Bicep. So that's very good. Thank you for that. One thing that I wanted to mention is that a few weeks ago you created a demo on the power of GPU and VDI machines. Do you have a video of this running Flight Simulator?
I actually do. So let me, happy to show that, of course. Yeah, so a couple of weeks ago, I've been experimenting with the Windows Virtual Desktop servers and trying to see if I could get advanced GPU scenarios working. So I started using Google SketchUp, which is a really heavy design application, but also started playing games from within Windows Virtual Desktop. Obviously, that's the more fun demo and fun lab environment to prepare. And you're right that as part of those demos, I created a flight simulator running inside Windows Virtual Desktop. So just to give a quick introduction, if you're not familiar or less familiar with Windows Virtual Desktop, it allows you to publish desktops to the end user that are running in Azure based on a remoting protocol. So similar to technologies like RDS, Citrix, VMware, etc. We are publishing a desktop to user based on a remoting protocol. And the Windows Virtual Desktop allows you to do that based on a platform as a service model. So without having to worry about all of the infrastructure components, we can really focus on the end user experience and focus on the session host itself. So as you can see, this is the, if you're familiar, this is the Windows Virtual Desktop client that we're taking a look at right now. And we're opening up a virtual machine inside Azure that is capable of using a GPU. In this case, it's the NVIDIA NV6 GPU. So the question is, can we ask, or can we play games from within that virtual machine? The answer is definitely yes. So here's the introduction of Flight Simulator 2020. So if you're not familiar with this game, it was introduced obviously many years ago, has been evolving a lot, and lately, I think a couple of months ago, 2 months ago, it has been released as the 2020 version. So here's that game running inside a virtual desktop in Azure and accessing it from my local machine. So as you can see, the performance is pretty good. We're getting a great overview of some of the demos of that introduction. And if we fast forward just a little bit, here's the game starting to load. So while we wait for that to happen, it was actually interesting to actually be able to install this game inside of this virtual desktop machine, because this game not only uses a lot of resources in terms of GPU and stuff like that, but also in terms of storage. So I actually had to expand my OS disk prior to even being able to install the Flight Simulator, because it takes way more than 127 gigabyte that the OS disk is by default. So here we click ready to fly, and we're taking off in this case from the Schiphol airport. Not sure about you, but I am not an experienced pilot. Not in real time, but also not in this game. So we're using the co-pilot to be able to take off from the airport. So I'm going to open a couple of connection properties. Actually going to close this one and take a look at the GPU performance as well. So we're leveraging the NVIDIA NV24 machine, which contains 4 dedicated GPUs inside a virtual machine and published to the end user based on a remoting protocol. So we are taking off from the airport and leveraging the GPU technology. So This was the first release of Flight Simulator 2020. In the meantime, I've seen a lot of updates come through for the game, but also for the actual NVIDIA card. They added a couple of updates specifically for the game as well, to even get a more better performance and better frame rates than we're seeing right now. And obviously, this is an example of a play hard scenario, I would say. But the same thing goes for design applications like AutoCAD and Autodesk and Google SketchUp, and all of those design applications that really require a GPU can leverage from that same GPU similarly. So it was a fun demo to create for sure. And yeah, if you take a look at my YouTube channel, you'll probably see some more videos related to this one, also including those examples of Google SketchUp and other games that I managed to play from within Azure Structured Desktop. So yeah, thank you for mentioning that, and happy to show it, of course, during this session as well.
There are no questions here. There are actually just thanks for the presentations here from the users.
All right.
So I wanted to thank you, and it's really interesting, and hope you will see you soon in Iceland.
I hope so too. Yeah. Thank you for having me. This was great. Thank you.
Okay. Thank you. Bye-bye.
Bye-bye.